Hi guys, hope you liked that last video. I'm sure you may mark that as one of your favorites of all time for me, or maybe not, probably not. This section we're going to be working on long division polynomials. The long division polynomials is a pretty mechanical process. There's a couple tricks that may throw you off, but I think you guys will find this a rather lighter section to have to work with. In this box here, we have just a few vocabulary words. Please make sure you're familiar with those on your own. And let's go and just review some long division that you may not have done in a while. I'm going to do 17 divided by 53,281. And you're more than welcome to use a calculator here. I'm going to go and do it by hand. If I do this by hand, I know 17 goes into 5 0 times. But I know if I look at the first two digits, 17 goes into 53 3 times. And if I multiply those together, 3 times 17, I get 51. I'll subtract those, put a 2, I'll bring down the 2, and the 8, and the 1. And now I have a new problem, 17 into 2281. And I look at 17 divided into 2, doesn't really work. But 17 goes into 22 exactly one time. 1 times 17 is going to be 17, and I'm going to subtract. And I hope you remember this process a little bit, because it's going to be really helpful when we have to do the work that we'll need to, the polynomial long division. So this means 53,281 divided by 17, or in other words, 53,281 divided by 17 is equal to 3,134 plus a remainder of 3, which is the same thing as 3 divided by the divisor 17. And if I add those back up again, I should get 53,281 divided by 17. Excuse me while I cannot read numbers and my voice cracked. So let's see how this fits in here. I just want to do this example first, and then we're going to do some polynomial long division. The zeros of x squared minus 5x plus 6, if you remembered from before, we can factor this as x minus 3 and x minus 2. And if we set this equal to 0, using the zero product property, we get x equals 2 and x equals 3. Now what I'm going to do is I'm going to relate x squared minus 5x plus 6 to the division algorithm. The division algorithm is basically taking what we have here, f of x equals the divisor times the quotient, and you get a remainder should be equal to a function. If I divide everything by d of x, this d of x cancels, and I'm just left with the quotient plus the remainder divided by d of x. That's what we got in this part. When I divided some number by a divisor, it gave me the quotient plus the remainder over the divisor. The trick is we're going to be using that with functions though. And we're going to take the function that we worked with up here as x squared minus 5x plus 6, and this time we're going to divide x minus 2 out. So here's how it works. We're going to do x squared minus 5x plus 6, and we're going to divide this by x minus 2. Now, just like I did in this last problem, I take a look at my divisor and I see how many times it goes in to the first couple terms, or the first couple numbers in the dividend. So x, and I'm going to ignore the minus 2, x goes into x squared x amount of times. Now, what I do next is I take this number here, x, and I multiply it times x minus 2, just like I did in the previous division problem. So I get x squared, and then I'm going to bring down x times negative 2, which is minus 2x. And remember what we did here. Once I did 3 times 17, I subtracted the number that I got. So let's go and subtract the x squared, and let's go and subtract the 2x, which is going to be a positive now. What do I get? I get negative 3x, and I bring down the 6 as a positive 6. And now I repeat the process. I'm going to take x, and I'm going to divide it into negative 3x. And if I take x and divide it into negative 3x, I get negative 3. So negative 3 should go here. Now if I multiply negative 3 times x, I get negative 3x. If I multiply negative 3 times negative 2, I get a positive 6. But remember, any numbers that we put down here after the multiplication need to be subtracted. So this guy needs to be subtracted, which is going to be a positive now. And this positive is now just a positive negative 6, or just a minus 6. I get a remainder of 0. So what we found is x squared minus 5x plus 6 divided by x minus 2 is going to be equal to x minus 3 with the remainder of 0. I hope this makes sense a little bit, some intuitive sense, because if we remember that x squared minus 5x plus 6 is factored into x minus 3 times x minus 2, well, we see that the factors could cancel, and we are indeed left with x minus 3. And you're thinking, Mr. Lakin, well, what the what? Why didn't you just show me that before? And the reason I didn't show you that before is because sometimes in our numerator we don't always know what the factors of the polynomial are. So we'll sometimes have to do long division on the polynomial to find the resulting quotient. This problem will be illustrative of that. I don't know how x cubed plus x squared minus 3 is factored. And I have no idea if x squared plus 2 is a factor of x cubed plus x squared minus 3. So the only way I could really do this problem then to reduce it is by polynomial long division. So I'll put the numerator inside the division sign, and I'll put x squared plus 2 as my divisor on the outside. And I'm going to erase one little part here, and you'll want to do the same because I need a placeholder. I jump from x squared to negative 3, and you may notice that I'm missing a middle term. So I'll put a plus or a minus 0x and then minus 3. Second, I take a look at x squared, my lead term, and divide it by my lead term. And I have x cubed over x squared, which gets me x. So that means x squared goes into x cubed exactly x times. In the last problem, I kind of put the numbers up here wherever I wanted. This time, I'm going to put x, the x that was the result, right above where it belongs with the other term. I'm going to multiply everything back together, so I'll get x times x squared, which will be x cubed. I'll get x times a positive 2, which is a positive 2x. Please note, any number that you put underneath here has to be subtracted. So this will be a minus x cubed. This will be a minus 2x. If we subtract, we get 0 here, so these cancel. I get a negative 2x. I'll bring down my minus 3, and I'll bring down the x squared. And I'll repeat the process. I'm going to take the x squared and see how many times x squared goes into x squared. And I think you may already know without me having to write it down that that will be a 1. A positive 1. So I'll put my positive 1 there. Notice the positive 1 is above the number in the dividend. And now I'm going to multiply the positive 1 times x squared. And that's going to be x squared. A positive 1 times a positive 2 will be a positive 3. Notice I'm putting the positive 3 again underneath the rest. I am not putting the positive 3 under minus 2x because they're not like terms. I'll subtract. So subtracting that term, this plus will now be a minus. And I end up getting, those terms cancel, I get negative 2x minus 6. Notice the positive 1 is at the end, which means I'm all done. So my final answer is, this quotient is going to be x plus 1, and then plus a negative 2x minus 6 over x squared plus 2. I want to make a little side note here. Notice we didn't get a remainder of 0. So no remainder of 0 means that x squared plus 2 is not a factor of the dividend. Now, I should also note that we could rewrite this as x plus 1. I could take out a minus out of both terms in the numerator, so I get minus. I could also take a 2 out of both terms in the numerator, so I could get minus 2, and then x plus 3 divided by x squared plus 2. And I do apologize for writing right over the part of the problem that we just did. So there it is separated. Either one of these answers would be fine. Please go on and pause the video and try this problem on your own. Good luck. Okay, let's see if we got the right answer. You needed an x to the fourth, a 3x cubed, and you need a 0x squared for the placeholder, plus an x minus 2, and we're seeing if x squared minus 3 really goes into this division, into this dividend. I'll start with the lead terms, and I get x squared. I'm not going to put x squared above the fourth or the third exponent. I'll put it over the x squared. So x squared goes into x to the fourth, x squared times 1x squared times. If I multiply those together, I get x to the fourth. I get a minus 3x squared. But I have to subtract. And hopefully, you were able to accomplish this first part on your own. If you didn't, please don't throw anything at me, because I think you'll miss. Unless you're in school, in which case you probably won't miss, but I would not recommend throwing anything at me. Second, we'll take the x squared and divide it into 3x cubed. And I will always write this part on the side because it's kind of easier to see that way. It looks like it's going to be a positive 3x. Positive 3x times x squared will be a positive 3x cubed. And then I'm going to get a minus 9x. I'll need to subtract. And I get those terms cancel. I get 3x squared. And I get plus 10x minus 2. The last one will be a plus 3. And if I multiply that out, I get 3x squared. 3 times negative 3 will be a negative 9. And when I subtract those, I get 10x plus 7. So what I get is going to be x squared plus 3x plus 3 plus 10, and then finally plus the remainder of 10x plus 7 divided by the divisor x squared minus 3. And this, my friends, is your final answer. Hopefully you got it right. Thanks for watching the video.